All right, here we go. We are going to look at this sheet right here for LeChatelier's practice. So if we look at the top, all right, as a forward reaction and a reverse reaction based on that generalized equation. And then it has some blanks. Chemical equilibrium occurs when the rate of the forward reaction equals, right, because that's the word we need for rate, equals the rate in the next blank of the reverse reaction, because rates must be equal. So what goes in the next blank? Concentrations of products and reactants remain constant. Okay? So rates are equal, concentrations are constant. And then you see a whole big table, right? That whole table you can use as needed to refer back to if you are confused about anything. I'm going to kind of talk about it as I do it, but that is a great resource if you need help. So we're going to go straight to the equations. And example 1 says if the pressure, okay, we kind of haven't talked about pressure yet, so let me model. I'm going to have this container right here, and then this container. This container has high volume, low pressure. Lots and lots and lots and lots of space. So this one has high pressure, low volume. So if I'm talking about moles of particles, this container with under low pressure has room for more moles of particles. And this container under high pressure with less volume has room for less moles of particles. So now what? Well, now I look at my balanced equation and I'm looking for coefficients in front. I have no coefficient in front of here. It is a gas, so that's a 1. It is a gas, coefficient of 3, okay? And that's it on this side. So on this side, I have 4 moles of gas particles. On this side, I have one thing, it is a gas, so I have 2 moles of gas particles. So my question, if the pressure is increased, so I'm using this model right here, right? The shift in equilibrium will be toward what side? Well, I need to go toward the side that has less moles of particles because I don't have a lot of space. That's here. So the shift to the right side or the product side. All right, next one. If the pressure on the system decreases, the shift in equilibrium will be toward, all right, so let's draw our picture really quickly, right? It helps. Low pressure, high volume. High pressure, low volume. This, remember, holds more moles, less moles. All right, so let's look at our equation. Gas, yes. Coefficient, no, so it's a 1. Gas, yes. Coefficient, no, so it's a 1. That's 2 moles of particles on the reactant side. Product side, it's a 2. Yes, it is a gas. All right, well, they're equal, so it'll shift toward neither side. No shift. There's not a side that has more moles or less moles, okay? All right, now we have this one, this equation. If N, the concentration of N2 increases, so let's increase N2. What's the crisis? I've got too much, use it up. So which way do I go? Toward the right side or product side. If NH3 increases, what's the crisis? I have too much, use it up. Go to the other side, right? It's on the product side, I need to go to the other side. So it will go to the reactant side or to the left side. H2 decreases. What's the crisis? Oh my gosh, I don't have enough. What do I do? What do I do? Make more. Make more. How do I make more? I need to shift to the reactant side, or that would be the left. Okay? And then if NH3 is removed, what's the crisis? Oh my goodness, I'm running out. I don't have enough. Make more, make more. How do I make more? I go to the product side or to the right. Okay, so now we're going to continue on here. Okay, so we have this equation. If O2 decreases, the equilibrium will shift where? So what's the crisis when it decreases? I don't have enough, quick, make more. Go toward it. So my equilibrium is going to shift this way. All right, so when it does, because now I have to fill out a whole bunch of stuff afterward, okay? So if the O2 decreases, equilibrium shift will be toward the reactant side, okay? That's the first part, which means that, so what will happen to all of those things, okay? So let me just switch this. Okay, so as the reaction shifts this way, right? Shifts this way, what happens? I start to use up this. I start to use up this. I make more of this, because see, here's where I shift. Okay, and why is that important? Because this was the crisis. I was running out of this. Making more of that is the goal, right? And then this is on the same side, so it will go up as well. So the first blank, HCl, will go up. H2O, it's on the other side, will go down, and Cl2, also on that side, will go down. So the things on this side both should go up, which makes sense because the things on that side will go down, okay? All right, let's look at this one. If H2O increases, what's the problem? I have too much. What do? I need to get rid of it. In order to get rid of it, I need to use it up and shift toward the other side. Why? Because when I use it, when I go this way, I start to use this up. This is on the same side, so it will get used up also. Here's my arrow, which means as I go this way, I will use this up, I will use this up, I will make more of this, and I will make more of this. All right, so let's see. The equilibrium will shift toward the reactant side or the left side. HCl, will go up. O2 will go up. And Cl2, it's on the other side. It has to do the other thing, will go down. All right. If pressure is increased, so let's make our little model for pressure. Okay, so this is low volume, high pressure. This is high volume, low pressure. So remember, this holds more moles and this holds less moles. All right, so what happened to pressure? Pressure increased. That's right here. Pressure increases, I want less moles. So let's count them. Gas, it has a coefficient of 4. Gas has a coefficient of 1. That's it on that side. 5 moles on that side. Then look at the other side. Gas has a coefficient of 2. Gas, coefficient of 2. 4 moles on this side. So my pressure was increased, right? So a shift toward the side with less moles. So I'm going to shift this way. So that is to the right. And then it says the amount of Cl2 produced will what? Okay, so when, let me switch pen colors here. When the equilibrium shifts this way, I will use this up, I will use this up to make more of this and make more of this, okay? So the amount of Cl2 produced will go up, all right? All right, one more question for this one. It's the opposite. Pressure is decreased. So remember our pictures, all right? So pressure is decreased. What's that? That's here. That means I have room for lots of moles, right? And we calculated it was 5, 4, and 1, 2, and 2, because they were all gases. So if I have more space, I'll go toward more moles of gas. So it will go to the left. And now I need to know what happens to something else. So let's switch a color. as the equilibrium shifts this way, this will get used up, this will get used up. I will make more of this and make more of this. So HCl will go up because I'm making more. All right? Okay, so this one, if the temperature is increased. So where's temperature? Well, it says kilocalories of heat. That's temperature. If I increase it, what's the crisis? I have too much. I need to get rid of it. I need to go to the other side, so I need to shift that way. So if the temperature is increased, it shifts to the left. And so then the next question says if the temperature is decreased. Why does it do that? Because if the temperature goes down, the crisis is, I'm running out, I need to make more. I would go this way, so it will go toward the right side. Okay? All right, now we have this one. Let's move this up. Okay, what would be the effect of each of the following on the equilibrium of methanol synthesis? All right, so removal of CH3OH. Remove this. What's the crisis? I'm running out. Quick, make more. Shift toward that side. So that is going to be to the right. All right. Now, what about the next one? An increase in pressure. Well, remember our little pressure diagrams, right? So increased pressure is here. So that's going to favor less moles. So let's look. No coefficient, 1. And these are gases, right? 2, so that makes 3 on this side. And only 1 mole of gas on this side. So I need to go where there's less moles. So I'm going to go this way to the right. Lowering the concentration of H2. So I decrease this. What is the crisis? I'm running out, I'm running out, I'm running out. I need to make more. How do I make more? I need to go this way. So that is the lowering the concentration of H2 is going to go to the left. Okay. What if I add a catalyst? No shift. Why? Catalyst just speeds up forward, speeds up reverse, so there's no shift in the equilibrium. They both just get faster. So no effect on equilibrium. All right, so, but we do have adding CO. So that's this. If we add it, what's the crisis? Oh my God, I have too much, use it up. So this way, I'm gonna go to the right. And then removal of H2. Well, we already did that one. That is the same as lowering H2. We did it right here, right? Removing and lowering is the same thing, okay? So it shifts to the left. So we have that one again, all right? And then we are on to our last one right here. Okay, which is CO plus H2O let me just rewrite this one. All right, so what are we going to remember? We are going to remember that pressure, high pressure, right, is low volume, which means it can only hold a small amount of particles, right? So I'm going to favor the side that has less moles. If I have a big space because I have low pressure, then I'm going to favor the side that has lots of particles, okay? Remember that we only count the gases. So if there was something in the equation that wasn't a gas, it wouldn't count to figure out which way it shifts for pressure, okay? Also, we would, let's see, if we change concentration, we're not going to be changing concentration of solids, right? We're going to change aqueous, all right? So there's a lot of things to think about, but let's get right to this one, okay? All right, first one, we're adding more H2O. So adding this. What is the crisis? I have too much of this. I need to get rid of it. So I am going to shift to the right or to the product side. Removal of some H2. So removing some H2. What is the crisis? I do not have enough. I need to make more. Go toward it, so it will go to the right or to the product side. Okay? And then raising the temperature. All right, so let's see what we got here for raising the temperature. Well, where's temperature? It would be represented with heat. So what is the crisis when you raise it? I have too much, I need to use it up. I need to go to the other side. So this one will go to the left. All right. Okay, so then, all right, let's go here. So increasing the pressure. So remember, we talked about this, right? This is increasing the pressure. So let's look. We have gas coefficient of 1. Gas coefficient of 1. That's 2 moles of gas on the reactant side, right? Then we have gas coefficient of 1. Gas coefficient of 1. This is not a gas, so 2 moles on this side. So which way does it shift? No shift. Okay. All right. So let's see. Adding a catalyst. Oh, catalyst is no shift. Right? What does the catalyst do? Increases the rate of the forward reaction, increases the rate of the reverse reaction. No shift in equilibrium. So if you remember from a potential energy diagram, if it looks like this, when you add a catalyst, we start the same, we end the same. All that happens is we lower this activation energy. So instead of needing this much energy, we need this much. That will definitely help the reaction occur faster. All right, the removal of CO. So remove CO. So sometimes it might help to think about this. See, here is where my arrow is. So this is one side of the equation, right? This is the other side. So when I decrease this, I need to make more of it. So I need to make the reaction shift toward that side, okay? So that will go to the left or toward the reactant side, all right? Lowering the temperature, okay? Well, temperature again is represented by heat. When you lower something, again, here is where my arrow is. So I have this side and I have this side. So either it's going to stay on the same side or shift to the other side. Well, if I need to make more of this because I'm running out, I need to go toward it. So it's going to go to the right or toward the product side, okay? Now what? Adding more H2. Here is where the two sides are, right? So if I add more, what's the crisis? I have to get rid of it. I have to use it up. So I need to go toward the other side. So it will go toward the left or the reactant side. All right, and then adding more CO. Add more CO. Here are our two reaction sides. What is the crisis? I have too much. I need to get rid of it. How do I get rid of it? Go toward the other side. So I'm going to use it up. Because if you remember from before, when I go this way, I'm going to use some of this up. That is the crisis that needs to be resolved. I will also use some of this up. And then on the other side, I will make this, and make this. Okay? So when I added CO, it shifted to the right. And then the last one, increasing the volume. Do you remember we had 2 moles of particles on this side and 2 moles on that side? So increasing or decreasing volume is the same as increasing or decreasing pressure, and there was no shift. So there was no shift for pressure, there is no shift for volume. And there we have it.